Welcome to Coming Clean, the podcast dedicated to common sense environmental dialogue, environmental optimism, and real environmental solutions. This show is proudly powered by Ørsted. Welcome back to Coming Clean with your host, Benji Backer. I am joined today by a good friend of mine who is in one of the most beautiful places in the planet, in my opinion, Maine, and excited to talk about that and some of the interesting things he's seen with conservative and liberal people in Maine talking about climate change. But before we get to that, I want to introduce Kerry Emanuel. He's a prominent climate scientist and really heralds from his leadership at MIT, which is a place where he's a professor, but also where he co-founded a scientific climate research program called the Lorenz Center. In 2006, he was named one of Time's most 100 influential people in the world, and he has been credited with well over 200 peer-reviewed scientific papers on the topics of climate and everything around that issue. Welcome to the show, Kerry, and thank you so much for being here.
It's nice to see you again, Benji. Thank you.
It's always nice to see you. I think back to our time when it was kind of middle of COVID, and I came to your place in Maine, one of the most beautiful places truly on the planet. And it's a place that you spend a lot of time because you love the outdoors and you love nature, but you also have seen something really interesting there that kind of leads into this discussion that I want to have with you about the politics of climate change and how you were remarking earlier about it doesn't seem to be a problem politically up there when you're talking about climate change. Can you elaborate a little bit on that and why you think that is?
Yeah, I mean, I've been saying for years that all climate change is local. And I mean that in analogy to Tip O'Neill's famous statement that all politics is local. So people believe what they see with their own eyes. And as I'm sure many listeners are aware, fishing is a very big industry up here in Maine, a big part of our economy. The Gulf of Maine has been warming as a body of water, has been warming much more rapidly than any other part of the North Atlantic Ocean for reasons that we're not entirely sure of. But it's wreaked havoc with the ecology and with fishing. Lobsters are changing where they breed, where they live. Certain species have disappeared and gone further north. Other invasive species have arrived. All this, of course, is noticed very much by the fishermen, and it affects their livelihood. So it doesn't matter. I mean, I know quite a few fishermen, and it really doesn't matter what their politics are. They're all quite concerned about this and wondering what's going to happen in the future.
Well, I love that example to start out just because it paints the picture that for a fisherman, it doesn't matter if you're right or left or don't care at all about politics. It's something that they're starting to notice. And one of the areas that we've talked a lot about in the past is how, to your point, climate change is local, but to a lot of people, it's not perceived that way in the way that the media talks about it and the way that our politicians talk about it. And the true reality is, and I hate to say this to you because you are the scientist, but most people don't care about the science itself in their day-to-day lives. But yet they should care, but it's just not at the top of mind, like those local examples, like the things that they can see and feel. So despite that, and I think you'd probably agree that most people aren't, immersing themselves into the science. Otherwise, we wouldn't have a lot of the problems that we do in the understanding of the issue. But what are some of, if you haven't seen the science and you're not going to read 100-page paper on it, or you're not going to read the annual reports, what are the key basic findings that people at this point should know about?
Well, I mean, the really basic science behind this isn't rocket science. In fact, this sort of warming was predicted at the end of the 19th century by a Swedish chemist, Svante Arrhenius. And it's fairly simple. It begins with the recognition that trace amounts of very important greenhouse gases are a big influence on our climate. If we got rid of the long-lived greenhouse gases, carbon dioxide and methane, the surface temperature of the planet would be close to 0 degrees Fahrenheit. We wouldn't be here to talk about it. There's no disagreement, and never has been in climate. Well, not for the last 100 years. We figured out how radiative transfer works in climate science about that. And Arrhenius was the first to recognize that burning fossil fuels would invariably increase the carbon dioxide content. There's no controversy about that either. It's going up, so is methane. We're well on our way to doubling what the pre-industrial concentration of CO2 was. And it's hard to believe that you can change this very, very important component of the atmosphere by a factor of 2 and not take any risks. So Arrhenius predicted that if you doubled carbon dioxide, you get about a 4-degree increase in the surface, 4 degrees centigrade increase in the surface temperature. And modern estimates are a little bit less than that, but there's a lot of error bars. Science is, I think, quite good about understanding the limits of its own knowledge. So somewhere between 2 and 4.5 degrees is sort of the modern estimate of what doubling CO2 will be. That's the basics of it. But to your point now, Benji, who cares? I don't even care about that number. I really don't. I mean, I care about it as a scientific curiosity, but it's not warming temperature for the most part that's a risk to us. What's a risk to us are extreme events, which are the first things, if you will, the canaries in the mine that change. So violent storms, heat waves, wildfires, and so forth are the concerns. And for those economists who work on the economics of climate change, it's really all about that and about the risks to the supplies of food and water, and about how shortages of food and water historically have led very often to armed conflict. These are the issues that we need to be concerned about and rational about.
Yeah, that makes a lot of sense. And, I feel like you're alluding to something that a lot of people get frustrated by, though, which is that they say, oh, well, extreme weather events, they've been happening forever. I've seen hurricanes and I've seen tornadoes and I've seen cold spells and warm spells and all these things my entire life. And everyone's blaming this stuff on climate change. And you've been in the crossroads of attacks from the right and the left for being, in my opinion, pragmatic, but for a lot of people, just not feeding into what they want to hear, to start at what the right doesn't want to hear. And then eventually, for those who are on the right, we will get to what the left doesn't want to hear, I think. But what would you say to those people on the right who do question and say, well, the world's been warmer, we've had these extreme events in the past? And I mean, even today, there were Instagram comments on an article that I had written, many Instagram comments saying, don't buy into this. This is a bunch of liberal BS. It's been warmer. There's been worse events. What would you say to those people?
Well, the interesting problem about extreme events is that almost by definition, they're rare, right? You take a tornado. How many of your listeners have directly experienced a tornado? Practically none, maybe literally none. It's a rare phenomenon. Hurricanes is likely that a few have, maybe once, maybe twice. They're rare, and it's a problem for science too, because if you have a theoretical expectation that something will change, but it's a rare event, you have to wait a very, very long time before you can detect a signal in the noise, and that doesn't bode well for people who say, "Show me the data." It's not like sea level rise or global temperature where you can see it going up slowly, but it isn't the thing that's going to get you in the end. So that's the dilemma. I think the way out of that is to try to persuade people, look, I mean, you can't really talk about the risk rationally before you understand what the costs of that risk are and the costs of dealing with the risk are. And I think the fear that many people have on both sides of the political spectrum is, how much is it really going to cost us to deal rationally for the risk? Are we going to have to give up driving big cars? Are we going to have to live with, are we going to be forced to move? These are the things that make people worry legitimately, I think, about that. And so I think that one has to understand that this is not just a question of risks, which are invariably negative. It's also a question of opportunities, right? Whenever there's a systematic change in anything, right? There are risks that go along with it, but there are also opportunities. And we have an opportunity here really to do a lot better, I would say. And this is something that's not so popular on the left, who are always about cutting back. I think we could actually increase and should increase our per capita energy consumption. And it's absolutely necessary for other parts of the world, for example, India and Equatorial Africa, to do this if they're going to conquer poverty. And who are we to tell them they shouldn't do that? So I'm for more energy, not less. And I think when you recognize this and you recognize the opportunities, it becomes a little bit less threatening, if you will, to take the risks seriously and deal with them rationally.
Well, and I want to get into the energy conversation because I think for most people, they wouldn't have heard that from a scientist before, or they haven't paid attention to scientists who would say, we expect more energy, we want more energy, that sort of thing. I want to circle back to that. But before I do that, why would, I think there's a lot of people who even care about climate change deeply who don't understand why extreme events would occur more. Can you just, in the simplest of terms, try to explain why that would happen? Because I agree that that's the thing people should be paying attention to, but why would that happen? Why should people care because of some moderate increases in temperature?
Yeah, I mean, it's a perfectly legitimate question. And the problem with answering it is the answer is different for each hazard. It's not this one answer does the whole thing. So I work on hurricanes, and hurricanes exist because the ocean, pardon me, the hurricanes exist because the ocean has to get rid of the heat it absorbs from the sun by evaporating water mostly. And so to evaporate water, it has to maintain a difference between the humidity of the atmosphere next to the ocean and the ocean. Otherwise, the water wouldn't evaporate. And the other way it loses energy is by infrared radiation to space. If you put more greenhouse gas in the atmosphere, it can't lose as much energy by infrared radiation. And since it's still absorbing the same amount of sunlight, it has to increase that evaporative potential so it can get rid of the heat by evaporation. But it's that evaporative potential that drives hurricanes. And I know that sounds very technical, but hurricanes are driven by the evaporation of water from the ocean. It's a process that transfers heat from the ocean to the atmosphere. It's the same process that happens if you get out of the swimming pool. Even on a warm day, water evaporates from your skin and makes you feel cold because it's taking heat out of your body. That doesn't disappear. It goes into the atmosphere, and it's an addition of energy. That's what drives a hurricane. The physics is pretty simple, and we already knew, 35 years ago, pretty much, that just putting more greenhouse gas in the atmosphere would allow hurricanes to become more intense, not necessarily more frequent. Press gets this wrong almost uniformly. Oh, it increases in frequency and intensity of hurricanes. No, it's just the second that we predicted would go up. We still don't really know very much about the first. So, yeah, communicating science is another problem, right? But now for wildfires, it's an entirely different piece of physics. When you go to a warmer climate, it's possible for it to get drier. I mean, in the same relative humidity, you can evaporate water much faster in a warm atmosphere than in a cold atmosphere, which is why the big deserts of the world are in hot places, generally speaking. So if the physics isn't very difficult, if you warm up a forest region, all other things being equal, if it doesn't rain more, it's going to get drier. It's in the summertime, particularly, and be more susceptible to wildfires. Now, of course, like anything else, when you get down to the details and you try to make it quantitative, like how much more dangerous, it takes a lot of work, and it becomes more and more difficult to explain it to people. But those are the basic physics behind those two risks. If you want to go into other things, one of the most important ones, though, I should say, because the physics is very elementary for that too, is as you warm the system, it becomes possible for a rainstorm to produce much more rain. The amount of water in the atmosphere goes up. But there's a law that says you really can't increase global rainfall very much at all. It's a very interesting law of physics, which means you have to compensate for that heavier rain by longer intervals with no rain. So there's a prediction that's all the models satisfy, but it's basic physics. You get more floods and more drought if you warm the planet. And that's a big deal for supplies of food and water and for flooding. And that's one of the things we worry about most because of its implications for inciting armed conflict, which historically food and water shortages have done.
Well, that's exactly right. And one of the things that I've also picked up, and tell me if I'm wrong on this, is that, because even a moderate increase in temperature melts more ice around the world. And when that ice melts, it has to go somewhere. So it either goes into the ocean, sea level rise, or it evaporates into the atmosphere, or both. Both is really what happens. But when that happens, there's more humidity in the air. And if it rains more, then, which is on average, from what I understand, supposed to happen, then when the droughts do happen, which they're still going to happen, there's more stuff to dry up and be sparked in a drought. So if Los Angeles gets more rain, a little bit more rain in the winter, the spring and the summer, it will still be drier. And because it got more rain in the winter, that stuff will be larger and be easier to be lit aflame. Is that correct, or is that the wrong understanding there?
Benji, it's absolutely correct in some places that have wet winters and dry summers. So there's plenty of vegetation around, and more so if it rains more. Yeah, so for Los Angeles and a lot of other places in the subtropics, particularly, that's correct. For big deserts where it almost never rains, it's already dry. It's not going to change things very much. But yes, so that is another concern. So there's an entire science, and I'm not completely up on that branch of science about wildfires and how they respond to climate change. Another issue are severe thunderstorms. So I'm working on that now because it's very interesting to me. Even if climate didn't change, just explaining the global climatology of severe thunderstorms that produce hail and tornadoes is already challenging.
Yeah, that makes a lot of sense. So two other questions that I know people on the right of center have, and then we'll move into more of like the left of center's thought process on this. The first is, when it comes to climate change, I oftentimes hear from the right that, well, what we have on this earth is what we were given. The CO2 has been somewhere this entire time. It's going to be somewhere forever. You're not going to get rid of it. It's always been part of our being as a planet. What would you say to people who say, well, you can't change matter, you can't change physics, who say that as an excuse that climate change can't be a thing, that it can't be controlled? I understand to you that it probably doesn't seem like a valid argument, but why isn't that valid?
Well, I mean, I could tell you by example. It's a very good thing that Ronald Reagan didn't buy that argument when it came to ozone. And he was convinced by his own Secretary of State, George Shultz, who used the argument, well, there are a lot of scientists who say that putting more chlorofluorocarbons in the atmosphere is really going to endanger us. And, why shouldn't we just buy an insurance policy on it and do what we can to stop it? We now know, and he did, he signed on to that. Now, of course, the protocols were actually signed under President Bush Sr., but Reagan backing was very important. And he was a very practical president. He didn't let ideology get in the way of reason. We now know from calculations that if we hadn't done that, we'd be in real trouble today. We'd be in real trouble. There's no question that we were destroying the ozone layer. There's not a single scientist out there who's a real scientist that studies this, not somebody posing as a scientist in the field, who doubts that we were destroying the ozone layer. Of course we can change things. We did. And we stopped it. Okay. And by the way, this country made a lot of money in the replacement of chlorofluorocarbons. This is something that I think people don't realize, is there's an economic opportunity here. And it's not all about giving stuff up. In fact, you're probably going to come out better in the end if you do things wisely.
I love that. And on that note, you've already said You want and expect more energy. You expect us to actually benefit from solving this problem rather than, hindering people's lives. The last question that people, I think, have that comes to mind the most is, well, with the UN, with the World Bank, there are all these international institutions who benefit by pushing a climate mantra, and that everyone is just kind of bought out by that mantra, and they're out there for their own benefit, and that this is just some globalist conversation to help the elites and the liberals in society succeed and for us all to fail. I've met you. I know you. I know you're not part of some crazy extremist conspiracy. But what would you say to those people, which I'm sure you've had to answer to in the past?
Well, look, I mean, there's no question that you're dealing, unfortunately, with a highly politicized arena in which we're trying to tackle these issues. It's too bad. I could go back to the 1990s and think of countless ways of moving forward that didn't result in this problem becoming politicized by it is. So there are all kinds of bad actors. There's no question about that. I wouldn't paint the big organizations like the UN as bad actors here, but there are bad actors who see this as an opportunity, if you will, in a negative sense, to make a killing at the expense of society. The existence of those actors doesn't make the problem go away, though, right? Scientists who work on this, and when I got into climate science, global warming wasn't on even our radar. We were just fascinated with the whole physics of the climate. People get fascinated in all sorts of things. We just want to know how it worked. And as I said, Svante Arrhenius, who lived at the end of the 19th century, he didn't care about the politics. He just wanted to know what was going to happen, and made an intelligent prediction based on basic physics. Now, you can say I don't trust experts, but you wouldn't want a climate scientist to be flying your commercial airliner. You would want a trained pilot to do that, okay? And you wouldn't want to take advice about the climate from a trained commercial airline pilot. You'd want it from a climate scientist. Are experts always right? Of course not. But non-experts are usually wrong. So where are you going to put your money?
I feel like those are a lot of the arguments that, I hear at the dinner table with older individuals, more conservative individuals, with skeptical individuals. But there's also a lot of conversations that happen with younger individuals, or maybe people more on the left as well, that also seem to question the science and question our ability of moving forward. And I actually want to go back to where you talked about more energy. How do you explain to a young person who believes in maybe the more, not Extinction Rebellion level, but humans are a cancer to the earth and we need to just kind of decrease our impact as quickly as possible, use way less energy, just completely change the way we live, transform the way we live? How do you rectify those thoughts with the reality that you know of as we are going to have more energy going forward? How do you see those two things converging, especially if we want to lower greenhouse gas emissions?
Well, I think you have to sort of step back first and look at the climate change problem in the context of a bunch of global problems. So I'm a climate scientist. It's not all about climate change. We have other problems. Let's talk about a big one, which is poverty. We still have terrible poverty in many parts of the world. And one side effect of poverty, ironically, is it leads to big growth in population, which, guess what, is one of the drivers of increasing greenhouse gas emissions. So poverty is bad from a number of perspectives. There's almost 1 billion people on this planet with zero access to electricity. Think about that for a minute. We just take it for granted. We flip a switch, the lights come on. Great. Okay. We can't be telling people who don't have electricity that they can't have any, or they can just have electricity in the day when the sun happens to be shining. It's not right, and it won't solve the poverty problem, and it won't solve population growth in the parts of the world that are very poor. To solve poverty and, in the process, slow population growth in those places, for sure, you need to give those people more energy per capita. So I'm a big fan of more energy, okay, not less energy. The left is all about, and has been for a long time, cutting back. And it's an ideological statement, and I sympathize with it at a certain individual level. Yeah, I don't like waste, okay? I try not to waste. That's a great thing. It's one thing to say that. It's another thing to tell people who are poor that they can't have what we have, and I'm not in favor of that. So it's unrealistic and probably unethical to say that globally we should reduce energy consumption per capita. And even if we succeeded in doing that in the developed world, it really isn't going to put much of a dent in the problem of what happens when India, Central Africa, and other places start burning energy. It's not going to help that much that we're not. So the best thing we can do for not just for the planet, but for ourselves and for people is to find ways of generating electricity both cleanly and cheaply. If we can't do that, I don't see a way out of this problem.
I really appreciate you saying that, because and just going back to your thing about, people deserve to have power for more than just when the sun is shining, it almost unveils this reality that I feel like the left really misses, which is that we're going to have a pretty diverse energy mix into the future. Can you expand on from why a scientific perspective would be also backing that up, in that at the current place that we are right now, and with current technology and the current forecast of future technology, that we need to not just rely on renewables only, and that there are other options that we know about and that we don't know about that are going to be a part of that? Why is that diverse mix important from a scientific perspective, or isn't it?
Oh, I think it is. And I mean, clearly there is going to be diversity globally, because there are certain places where energy of certain kinds is plentiful and other kinds of energy are not. So take Iceland. Plenty of geothermal, cheap geothermal, so go for it. It's not going to work in New York City. Here's the problem.
Could we try geothermal in New York City?
There's a, yeah, I suppose. It'd be interesting to see what happened. But, there's a lot of disinformation, and journalists are unfortunately unwittingly participating in it. Everybody talks about the price of renewables going down, down, down. And what they're talking about is the capital costs of solar PV windmills, and they're right about that. It is going down. The problem is that unless you can come up with cheap storage, okay, you're going to rely on the rest of the grid to carry you through darkness and days when there isn't, or sometimes whole weeks where there isn't wind. Right now, battery storage, pumped hydro, all the other means of storage that have been investigated are just plain way too expensive. Yeah, maybe you can convince a wealthy town in California to do it. It's not going to solve the problem for India. That's the bottom line. Now, maybe a miracle will happen, and I hope it does, in which we just come up with really cheap storage, all right? And we should be putting a lot of money into that, all right? In the meantime, we have to be realistic and stop talking about the costs of renewables without talking about the cost of storage, because you can't have one. You can't have the renewables without the storage unless you have a grid that's usually today powered by fossil fuels. You're not going to solve the problem. And it's just plain mathematics, right? It isn't going to work. Even if it could be made to work in the developed world, it's not going to fix the twin problems, or the triple problem of poverty, population, and energy in the third world. We do have a solution, and it's a very good one. It's nuclear power. But the problem with nuclear power in the developed world, in the highly developed Western world, is, I know people are going to be shocked when I say this, it's just plain too safe, and therefore it's too expensive. We made it because of a lot of scare tactics over the years about nuclear power. We've made it the threshold for safety to be zero accidents, and that's not realistic, okay? It's not going to happen.
Right.
But so you could make an airplane twice as safe today, commercial airliner, at the cost of doubling the price of the ticket. What would happen if you did that? People, instead of flying, would get in their cars, and a lot more people would die. Okay. That's exactly what happened with nuclear power. We phased it out, and guess what replaced it mostly in most places? Fossil fuels. And fossil fuel particulates today, having nothing to do with climate, are estimated to result in the premature deaths of 8.7 million people a year globally. All right, which is a Chernobyl every 3 days. All right. So Chernobyl won't happen again because we know how to prevent that. But we might have a 3 Mile Island which killed nobody and harmed no one, but scared a lot of people because of the emotional content of that. So we're living in a very, very irrational view of this. Climate risks, and particularly the direct risks of fossil fuels because of their particulate emissions, are way, 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 way more than the risks of nuclear power as it's practiced in the West. Now, South Korea, to take a counterexample, routinely manufactures nuclear reactors for very reasonable capital costs and very low operating costs. And so I would argue, and yes, there's an issue of nuclear waste. It's a political issue. It's not a technical issue. We do know how to deal with it. We do have the solution, and the solution does not require anyone to give up anything except mythology about the dangers of nuclear power. That's what they have to give up. They want to cling to their no nukes, fine, but you have to live with the consequences of having much more dangerous power sources around you. So
you would go would you go as far to say that even if it's unintentional, being anti-nuclear is the equivalent of being pro-coal, pro-oil and gas?
Well, that's the effect. Certainly it's the effect.
Unintentionally or intentionally, that.
Yeah, so Germany, to compensate for the fact that it's had to, and I'm glad they did, shut off Russian gas because of Russia's behavior, because they also shut down their nuclear powers, have to step up, among other things, coal combustion. It's terrible for the environment. It's terrible for people. 60,000 German lives a year, or deaths a year, are attributed to coal combustion there.
And that decision, by the way, from Germany to shut down nuclear and its own natural gas opportunities as well, has resulted in more coal, which is the very coal that was being protested by Greta, who I testified at Congress with. And I'm not saying Greta is to blame for this, but there is a mindset within the climate community of solar and wind only, nuclear is not included. And then people are surprised when Germany needs to reopen coal plants because it doesn't have the reliable energy 24/7 that it needs to survive. Do you feel like that mindset, although well-intentioned usually, to go solar and wind only, is harming and bringing back the conversation in a way that we could be moving forward without that?
Well, so the whole thing is just so loaded with ideology, it's impossible to know where to begin to talk about it. Why are environmentalists so enamored of solar and wind? I think it's because of a kind of ideological misconception that small is beautiful. And I sort of sign on to that too. I actually have solar panels all over the roof of my house here in Maine. It is. But the problem is to make solar and wind work on a grand scale, it's big business. Okay, you think nuclear is big business. It's huge industrial plants. It's not going to be solved by everybody putting solar panels on their roof, their rooftops. So it's big industry too. There's a misconception there. But the ideology is there's a lot more to the support for wind and solar than a mere misconception that will solve the problem. Okay, there's a lot more to people's embracing that technology that's deeply social and psychological than a mistaken belief that it's the solution to the problem. Now, someday it might be, if we have a miracle breakthrough in storage, great.
So yeah, I think we all agree that a breakthrough on wind and solar storage of energy to enhance the reliability, a breakthrough on that is what we want and what we could hope for. But what you're saying, and I think I agree with this completely, is that we can't rely on that breakthrough. And that's why we have to be pursuing other alternatives like nuclear, assuming that we don't hit that breakthrough. Is that right?
Yeah, we can't take that gamble. But I'm strongly in favor, obviously, of doing a lot of research on that. It's not clear to me at this point, from an environmental standpoint, that if you did have cheap storage, that it would be worth destroying so many acres of forests and decimating. The fishermen here in Maine are dead set against offshore wind because it takes huge tracts of underwater out of commission for bottom fishing, which is, among other things, what lobsters are, right? So it's not clear to me that the environmental impacts of massive solar and wind are less than building nuclear power plants, which take up far, far, far less land per kilowatt hour generated than solar or wind. So I think we ought to look at this problem more rationally. We cannot afford to take off the table anything that seems like it might work, and that includes solar and wind and nuclear.
Well, and what I like about that is, and I've toured offshore wind, and I'm a huge fan of it. I've toured solar. I'm a fan of it. I'm a fan of these different energy sources, but we have to be realistic that they all have drawbacks, right? There's no perfect solution. There's no perfect solution in general, right? You can't just have 100% solar and wind and say, congrats, we did it. There's also no perfect solution in terms of what is harmed in the creation of that reality. If we did have 100% solar and wind, we would have issues that we don't talk about enough. And if we had 100% electric vehicles, we'd have issues that we don't talk about enough. That doesn't mean that those are bad ideas. The point is that there are drawbacks to each of them that we aren't looking at holistically, but that we've been honing in on natural gas, nuclear. We've been honing in on the negatives of certain industries, and we have not been honing in on the negatives of others. And before I, change topics on this, do you feel like there is that reason of honing in on the negatives of some and not the negatives of others? Have you heard that as a reason for pushback from people who are skeptical of climate change, and that maybe if we took a more holistic approach, people wouldn't be so skeptical?
Well, every time you put up a wind turbine within earshot of somebody's house, you've lost one supporter or a family of supporters. There are environmental drawbacks to this that are not being recognized necessarily the way they should be. There's a lot of toxic heavy metals like cadmium in today's solar PV. Not much control over where that winds up after the 15 to 20 year lifetime of a solar cell. There are all kinds of drawbacks, but I think that as a climate scientist, what I'm interested in is a rapid transition from fossil fuels into something. And I wouldn't even mind fossil fuels if we figured out, this is another thing we haven't talked about, though, figured out how to take the carbon back out of the effluent or the atmosphere itself. Then there's not much downside to natural gas. Coal still has the big problem of particulates. So the thing is that we have to make the transition quickly. Now, back in the 70s, when there was the first Middle Eastern oil shock, countries that didn't have a lot of fossil fuels, like Sweden, France, and Switzerland, built out nuclear power very, very fast. Within 10 to 12 years, France and Sweden had completely decarbonized their electrical generation, not other sources of energy generated, but electricity, yes. That's fast, and solar and wind are not making anything like that rate of progress. They did briefly in Germany, but then they had the brick wall of intermittency. where they had the price of electricity was going negative in the day, windy days when there was a lot of sun, and then very, very positive at night when Germany was having to supply all of its power by drawing from other neighboring countries. And the volatility of the electrical grid was getting out of hand, and basically they had to stop their expansion. And that's what the energy experts, I know people don't like experts, had predicted. You get up to 30 or 40% of your total electrical generation by intermittent sources, you're through, right? You can't go further than that, barring, again, a breakthrough in storage. You have to draw power from other sources when you get up to that level.
Well, so I've got two final questions because I know we're short on time. The first of those is, understandably, this might seem like an obvious question, but a lot of people on the left would say, well, okay, I get it. The nuclear renaissance is happening. People are buying into it. It's a really good idea. The scale is necessary. It's safe, whatever. We don't have time. We don't have time to build the nuclear plants. We don't have time for the research to come together. We don't have time for a lot of these things to happen. Now, I know what I would say is my answer to that, but what would your answer to that be to those sorts of people who I'm sure have brought this up to you in the past?
Well, it's not a threshold phenomenon. It's not like you get to a certain point and the world ends and we're trying to avoid that point. It's not like that. I'm not a part of the apocalypse crowd, okay? It's notwithstanding that there might be tipping points in the climate. It's a gradual thing, and the sooner you can stop putting greenhouse gases in the atmosphere or start taking them out, the better off you are. So why not go with a strategy that accelerates that? I don't really expect a nuclear renaissance in the West because we've made it way too expensive. The capital costs are just too large. The operating costs are very reasonable, but you have to get there, right? I'm in favor of buying nuclear power plants from South Korea, who, by the way, are using a design invented in the US by Westinghouse and already approved by our Nuclear Regulatory Commission. Whether South Korea could meet that demand in a reasonable time is another issue. But we have got to start thinking creatively and stop letting ideologies block progress. I mean, if the left, the crisis wing of the left, insists that this is an existential crisis for the planet, then they have no excuse to deny sources of energy, clean sources of energy that'll get us there quickly.
Right.
Especially since they're safer than the other ones.
That's the funny part about it, is that nuclear does take a little bit of time, and it does take a little bit of effort to get it off the ground. But it's the quickest that we can do at the scale that we need. And so, yeah, it takes a while, but it's the quickest we can do at the scale that we need to at the current technology level that we're at. And again, to your point earlier, that doesn't mean that we don't invest heavily in other solutions as well, and that we just write them all off. It's just we need to be really open to that. And if, AOC tweets that by 2030 we need a Green New Deal, otherwise we're all going to, internally combust. A, that's not scientific, to your point. But B, if we want to get somewhere quickly, nuclear is as of right now one of the quickest answers. And the U.S. has made it nearly impossible to do it here, which is why countries like South Korea have been taking these ideas, and Bill Gates and others have been going internationally with their ideas because the U.S. market is just so tough.
It's very, very tough. And, one can hope that would change. But right now, all I can tell you, Benji, is that several countries did decarbonize their electricity really fast. 10 years on this sort of thing is really fast, much, much faster than we've been going with solar and wind. So we've done it. We've done the experiment. We know we can do it, but we lack the will, and we're now, the regulations of nuclear are just completely out, stopping anything intelligent from happening at this point. So.
Well, I could literally talk to you for hours because I love the way that you look at this issue, and I think America could benefit from listening to Kerry Emanuel a whole lot more. My final question, though, because I unfortunately know that we are at time, is something that you just touched on a little bit, which is that there's some hope. There are examples of places where things are working in the United States and abroad. As a scientist, what would you tell young people who don't really know where we're headed? They're anxious about it, they're depressed about it, or even just frustrated about it around climate change? Where are you seeing hope, and where should they be focusing their attention in terms of this issue from that more positive standpoint?
Well, I would say two things. That from a sort of social psychological view, they should start emphasizing the benefits of a transition in energy, benefits that would accrue even if we didn't have to worry about climate change. If you've ever driven an electric car, you will never go back to a gas car. Forget about climate. It's just much better. The maintenance costs are far less, and they accelerate much faster. They're better cars.
Americans do love speed.
Yeah, if you like speed, you're in good shape. I mean, that transition is going to happen, climate change or no climate change, just because it makes perfect sense for it to happen. So start emphasizing the good things, the idea of cleaning up the air, that we could eliminate almost 9 million premature deaths a year globally, that if we had cheap green energy, we could not only solve the climate problem, but lift a lot of people out of poverty in other parts of the world, which I think is very important, and thereby also control the growth of population. People get richer, they tend not to have as many children for whatever reason. So there's a lot to be upbeat about. I think if you're going to make a difference aside from sort of psychologically, socially, it's going to be in technology, right? We've got to come up with the technology. I think this problem is going to be solved, if it ever is solved, by good advances in technology. I'm not smart enough to predict what that technology will be, but we can't afford to take clean energy sources off the table for ideological reasons that aren't backed up with hard data.
So you would say, as of right now, 2023, early 2023, you are hopeful about our path forward on this topic?
I very guardedly hopeful. I mean, sometimes we all get surprised by each other and we sort of finally figure things out, get going, maybe late in the day. I remember how hard Franklin Roosevelt tried to convince Americans in the late 30s that there was a threat called fascism going on in Europe and Japan, and that we had to take it seriously. And no one did. 10% of the American public thought we ought to be doing something about that for a long time. And Franklin Roosevelt was very frustrated, and other people were as well. And then an event happened which in a military sense was inconsequential, but in a psychological event was very consequential, and that's Pearl Harbor. Everything changed, and we did confront that problem, and we did solve that problem. Now, with climate change, it's probably not going to be one big Pearl Harbor that comes along and changes people's mind. Lots of little ones. Every time, there's a Hurricane Sandy, a lot of people in New Jersey and New York suddenly had a different idea about climate change, or a hurricane in Miami. Or a wildfire in California. All these are little Pearl Harbors, and they're doing much more to change people's minds than proselytizing by people like myself.
Well, I will say that big P word that I won't be able to pronounce, and I've never been able to pronounce, that you just said that you do, is appreciated by many. The ability for you to explain this in a way that is holistic, that is pragmatic, is appreciated. I think people on the left appreciate the guarded, at least hopeful, or hopeful, but in a guarded way approach. People on the left probably appreciate the fact that you're looking at this from a pro-nuclear, kind of open-minded perspective. And people on the right appreciate that you don't want people to give things up. You want more energy. You want more ability for people to thrive. And these are the sorts of arguments that maybe they're normal in the scientific community. Maybe you are actually the norm in the scientific community, but that's not what we hear. And your thought leadership on this, as someone who knows it in and out, one of the most distinguished scientists on this topic that I've ever run into in the United States, let alone the world, it is appreciated. And I wish more scientists would lean in the way you do, because it inspires so many. And I appreciate you joining us.
Well, thank you very much for your kind words. It's been a pleasure being on your podcast.
We'll definitely have to have you back because this was fascinating, and we know we have hours more that we could talk about.
It's a deal.
And before we jump, the Coming Clean podcast is grateful to be powered by Ørsted, a wonderful company strengthening America's energy security with reliable and domestic clean energy. Through its integrated renewable energy solutions, Ørsted is creating American jobs, investing in American communities, and driving American innovation, all while preserving our country's natural habitats. A clean energy future truly connects us all, and Ørsted is helping lead the charge. To learn more, visit us.orsted.com.